The next one is layout for readers and then antennas. This is very important because the placement of antennas around the RFID reader, it determines coverage, tag detection accuracy and read range. So layout of RFID reader and antennas, it includes the reader module, antenna subsystem, and typical layouts having single antenna layout and dual antenna and multi antenna layouts also, and also having overhead antenna layouts also. So comes to when key considerations in layout, it coverage the area and it have the polarization level and it reduce the crosstalk, and its applications of layout, it depends on use case like portal, conveyor and handheld scanning and shelf monitoring. So in an RFID reader sits at the center and connected to one or multiple antennas placed strategically. It may be side or top or bottom or overhead. It's to create a full read zone. So the number and arrangement of antennas depends on the environment and then tag orientation. Then comes to when categories. So categories of RFID, it includes the portals, tunnels, handheld and forklift and then smart shelves. I will explain one by one. The first one is portal. So what is this? It means fixed readers with 2 to 4 antennas mounted around doorways, dark doors or gates. So this is an RFID portal. So how it works, as tagged items pass through the portal, antennas on both sides just read the tags. The application is warehouse shipping and receiving, inventory movement tracking. For example, layout is antennas placed on the left plus right side of the dock door, sometimes in top. It to ensure 360-degree coverage. The second one is tunnel reader. It means antenna placed inside a tunnel structure, often built around the conveyor belt. How it works? It means items with RFID tags pass through the tunnel and antennas from all sides reads tags simultaneously. So applications in the sense, it have high speed conveyor systems in logistics, airports, in even parcel delivery also. So it's an automated item level scanning. What is the benefit while using tunnel reader? Which means it captures multiple tags in motion with high read accuracy. Then comes to when handheld reads. It is an portable devices like scanners with an integrated reader plus antenna. How it can be work, which means it operates walk around manually, scan the tag by pointing at items. So it's probably we are seeing its application is retail stock counting and library book management and even healthcare like medicines, equipment tracking like that. So its benefit is mobility. So on demand scanning works where fixed systems are not practical. Then comes to when forklift, it has a RFID reader plus antennas mounted on forklift. It works as the forklift moves pallets in or out. It automatically scans the RFID tags. Its applications like it's in warehouse management, it just tracking the pallets in real time, and yard management systems, and benefits is it just eliminates manual scanning and provides real time locating data. Then comes to when smart shelves. Shelving units with RFID antenna embedded inside or under the shelf. How it works in the sense, items with RFID tags placed on shelf are automatically detected. So the shelf monitor presence, removal and replenishment of items. Here the applications is retail stores for detect theft and stockouts, even in libraries for bookshelf monitoring, in healthcare using medicine storage and expiry checks also. Then comes to when benefits of this, it enables real time inventory visibility without manual counting. The next one is a simple lightweight RFID reader protocol. So in an RFID system, especially for low cost passive tags, its an protocol needs to be lightweight because tags have limited memory, no battery and minimal processing power. So a lightweight RFID protocol is a communication and security mechanisms. It is designed to use very few computational resources and be low cost, and it's provide basic security and then authentication, and it ensure fast tag reader communications. So it's often applied in supply chain, inventory, retail and then ID codes where millions of tags are used at very low cost. Then futures of lightweight RFID protocol, it is low consumption, low memory footprint, even in fast authentications and basic security against replay and then trackings. Then it achieve the better scalability also. For example, yeah, that so for example, the lightweight RFID protocols used in hash based protocols. Example, one way hash based light weight protocol, and challenge and response protocol, that is an random number protocols, and XOR based protocols. So use XOR operations between key random numbers and EPC ID. So it extremely lightweight and then fast. And lightweight mutual authentication protocol, it's an both reader and then tag can authenticate each other. So these are all the protocols in lightweight. So a simple lightweight RFID protocols, it having the same reader, tag reader, and mutual authentications having both reader and then tag. So the benefits is ultimately it's a very fast and cheap, and it's reduced computational overhead. But the limitation in the sense, it's a weaker security compared to heavy cryptographics, may be vulnerable to advanced attacks like relay desynchronization and maybe in impersonations. So I have concluded that a lightweight RFID protocol is a simple, efficient and low cost communication method that enable authentication and secure tag identification using minimal operations, making it ideal for passive tags in supply chain, retail and then logistics also. So this is shown as RNC. So RNC generally sits between the reader and then RFID middleware. So the RNC is an intermediate control layer between multiple RFID readers and then middleware or application layer. So RNC is reader network controller. Okay. So why RNC is needed in the sense, for an large systems there may be dozens or hundreds of RFID readers is there. So sending all raw tag reads directly to middleware would cause high network traffic or duplicate reads and unnecessary processing load. So RNC solves this by managing the readers and delivering clean and aggregated and filtered tag events. Its functions is reader management, data filtering, aggregation, event processing, load balancing, interface with middlewares. These are all the main functions of RNC.